Hello friends, in today's video we shall go through the O-ring theory of economic development. The O-ring theory of economic development was put forward by Michael Kremer in 1993. He stated that modern production requires many activities to be done simultaneously in order for any of them to achieve a high value. What he meant is that many production processes consist of a series of tasks or activities as well as mistakes, and any of those mistakes can dramatically reduce the product's value. Say for instance in the case of television, right from its production till its delivery to the customer, each and every process should be carefully undertaken for its proper production as well as proper delivery to the customer. Now suppose if due to some mishandling or improper packaging, if there is a scratch or dent in the television, then the full value of that product cannot be acquired from the consumers in the form of its price. So just because of a simple error from any of the workers, the television got a scratch or a dent, which is why the value of the product has been reduced. And because of that, the producer will have to sell that defective product at a reduced price to the customer. Kremer took the name O-ring theory of economic development from the 1986 space shuttle Challenger disaster, in which the failure of one small inexpensive part caused the space shuttle to explode. Now the Challenger had thousands of components, but it exploded because the temperature at which it was launched was so low that one small component, which is called the O-rings, malfunctioned. So, in a similar manner, Kremer proposes an O-ring production function in which the production consists of many tasks, all of which must be successfully completed for the final product to have its full value. In other words, there must not arise a coordination failure among the various tasks involved in the production process. Now, what do you mean by a coordination failure? It simply means a state of affairs in which the agency's inability to coordinate their behavior leads to an outcome that leaves all the agents worse off. To put it in very simple terms, coordination failure is nothing but failing to coordinate among various tasks. We already saw the case of television wherein coordination failure led to a scratch or a dent in the television, which is why its value was reduced. Similarly, a defective garment with a stain or a skip stitch, or say any slight imperfections or defect, will be sold at a half price. Similar is the case for any of the defective electronic appliances. So consumers would be willing to pay the full value of the product only if the product is of high quality without any defect. But even due to minor coordination failure among different agents, the products become defective even in the slightest way, which reduces the value of the product, and thereby the full value of the product cannot be acquired from the consumers in the form of its price. So Kremer proposes an O-ring production function which involves completing a series of tasks successfully, and failure of any one task will reduce the product's value to even zero. For example, now suppose a production process is broken down into n tasks. A worker's skill or quality at a task is denoted as Q, and this Q, which is a worker's skill or quality, can be defined as the expected percentage of the maximum value the product retains if the worker performs the task successfully. And also the value of the Q lies between 0 and 1, which means the higher the level of the skill the worker has, the higher the probability that the task will be successfully completed. Now for instance, if Q is equal to 0.95, then it can be interpreted in three different ways. Firstly, it could mean a worker with a 95% chance of performing the task perfectly and a 5% chance of performing it so badly that the product is worthless. Secondly, it can be interpreted as a worker who always performs a task in such a way that the product retains 95% of its value. And finally, it can also be interpreted as a worker who has 50% chance of performing the task perfectly and a 50% chance of making a mistake that reduces the value of the product to 90% of its maximum possible value. So if you see this assumption in a numerical way, there is a 50% chance of performing the task perfectly. So that can be denoted as 0.5 multiplied by 1. And also there is a 50% chance of making a mistake, which reduces the value of the product to 90% of its maximum value. So that can be represented as 0.5 multiplied by 0.9. So when you solve this, we get 0.95. So with this in mind, the O-ring production function can be written as y is equal to k raised to alpha pi n I is equal to 1 qi multiplied by nb. Here y is the total output, k raised to alpha represents the fixed capital, q is the worker's skill. The term pi n I is equal to 1 qi represents the output which is given by multiplying the q values of each of the n tasks together. That is, we have already stated that there are n number of tasks, and for each task a worker with a particular q skill is assigned. So if each of those q values for those n number of tasks is multiplied together, we get the term pi n I is equal to 1 qi. And here capital B denotes the output per worker if all the tasks are performed perfectly. So this production function can be written in a much simpler form as y is equal to k raised to alpha multiplied by q1 multiplied by q2 multiplied by q3 etc. up to qn multiplied by nb. This equation can again be shortened as y is equal to k raised to alpha multiplied by q raised to n multiplied by nb. This O-ring production function was given by Kremer by maintaining 5 assumptions. So the first one was, it is not possible to substitute several low-skill workers for one high-skill worker. It mainly meant that more preference was given to quality rather than quantity. For example, it is not possible to replace one excellent chef in a restaurant with two mediocre chefs. So here, more importance is given to the quality rather than the quantity. The second assumption is that the probability of errors made by different workers is strictly independent. It means that if at all any errors are made by the workers, those errors are strictly their fault and is not dependent on any of the other workers. The third assumption is that firms are risk neutral. It means the firms are neither risk lovers nor risk averters, they are risk neutral. The fourth assumption is that labor markets are competitive in nature, which means the workers are paid wages equal to their marginal products. And the final assumption is that workers supply labor inelastically. If the workers' labor supply is inelastic, it means that the percentage change in the quantity of labor supplied is lesser than the percentage change in the wages. Usually, when wages increases, people tend to work more. So here, when it is stated that the workers' labor supply is inelastic, it means that a large increase in the wage will lead to a smaller increase in the number of working hours of the people, or say number of people who are ready to work. Similarly, a large decrease in the wages will lead to a small reduction in the number of workers who are not willing to work at that reduced wages. It means that even if the wages has reduced by a larger percentage, majority of the workers are still willing to work at that reduced wages, but only a small proportion of workers are not willing to work at that reduced wage. That is what is meant by inelastic labor supply. So with these 5 assumptions, Kremer has discussed the O-ring production function. One of the most noticeable features of the O-ring production function is the positive associative matching. Now, what it means is that the workers with high skills will work together and the workers with low skills will work together. Now, suppose if we are talking about the positive associative matching in the case of economies, then it would mean that the high quality products will be concentrated in countries with workers having high value skills. Now basically everyone will like to work with more productive workers, because if your efforts are multiplied by those of others who has the same skills, then you will be more productive when working with a more productive group. So here comes one of the key feature of the O-ring model, which is complementarities. Specifically, production with strong complementarities among inputs is considered in O-ring model. So what do you mean by complementarity? It can be defined as an action taken by a single firm, worker or organization or any agent that increases the incentives for other agents to take similar actions. The action of a worker, say like taking up a training for improving their skills or taking up a course for improving their experience or productivity, it increases the incentives or it motivates other workers to take similar actions. Complementarities often involve investments whose return depends on further investments being made by other agents. So we can see this sort of strategy in the unbalanced growth strategy of Hirschman. Hirschman also proposed that investments should be made in strategic sectors or leading sectors of the economy so that those investments can pave way for further investments in its associated or related sectors. In a competitive market, a worker's pay is based on how productive he or she is. So this can be associated with the marginal productivity theory of distribution, wherein the workers are paid rewards or remuneration equal to their marginal products. Also, a firm with a higher productivity worker can afford to pay a higher wage and also has the incentive to bid higher as well, because the value of the output produced by the two productive workers will be higher compared to one low and one high productive worker. It means higher productivity, higher wages, and the workers with higher productivity also has the incentive to bid higher wages. So this can be associated with the efficiency wage model, which states that higher pay will make the workers more efficient and it will also reduce the worker turnover. As a result, there will be a strong tendency for the most productive workers to work together. Now, this can be explained with the help of an example. Suppose that there are two high-skilled workers denoted as QH and two low-skilled workers denoted as QL. Now these four workers can be arranged either as a matched skill pairs with two high skilled workers and two low skilled workers, or an unmatched skill pairs, that is with one high skilled and one low skilled worker together. But the total output will always be higher under a matching scheme, because QH square plus QL square is greater than 2QH QL. So this equation simply means that the output produced by a matched skill pair will always be greater than the unmatched skill pair. Now we can see this with the help of a numerical example. Now suppose QH is equal to 0.8 and QL is equal to 0.4. Now if we substitute these numbers to the equation and solve it, we get 0.8 square plus 0.4 square is greater than 2 multiplied by 0.8 multiplied by 0.4. If you simplify this, we get 0.64 plus 0.16 is greater than 0.64, and finally solving this, we get 0.80 is greater than 0.64, which basically proves that the total output will always be higher under a matching scheme rather than an unmatched skill pair. So, the firms with high skill workers can and will pay more to get other high skill workers, and they may also have more incentive to upgrade the skills of their existing workers as well. Now, this can be explained with another numerical example. Suppose there are 6 workers, wherein in the first firm there are 3 workers with a Q of 0.4, and in the second firm there are the other 3 workers with a Q of 0.8. So we can see here that in firm 1 we have the low skilled workers and in firm 2 we have the high skilled workers. Now suppose if the Q of one of the workers in the first firm rises from 0.4 to 0.5, just a 1 point increase, it can be possibly due to some training or attending a course, etc. Similarly, in firm 2 also, if the Q of one of the workers increases from 0.8 to 1, it means there is a 2-point increase in the quality of the worker in the second firm. So in each of the case, we can see a 25% increase in the quality of one worker. So a 25% increase in the worker's quality will lead to a 25% increase in the output quality as well. But if you compare this 25% increase in firm 1 and 2, we can see a wide difference. That is, in the first firm, before the improvement of that one worker, the total quality of the worker constituted to 0.064. That is, if we multiply the Q values of all the 3 workers in the first firm, we get the value 0.064. And when one of the workers' Q value increased from 0.4 to 0.5, the overall worker's quality increased from 0.064 to 0.080. So here we can see a clear difference of 0.016, which is a 25% increase. Similarly, if we observe the second firm, before the improvement of one of the workers, the overall quality of the 3 workers was 0.512. And when one of the workers' quality increased from 0.8 to 1, the overall quality of the workers increased to 0.640. So here the change is 0.128, which is again a 25% increase. So if you compare firm 1 and firm 2 with regard to the workers' quality, we can see that there is only a 1-point change in the first firm in the case of the quality of the worker, whereas there is a 2-point change in the quality of one of its workers in the second firm. And comparing the change in the overall quality of the workers in firm 1 and 2, we can see that compared to firm 1, the quality of the workers in firm 2 has increased 8 times as that of firm 1. So this example shows that the firms will be more incentivized to upgrade the skills of their existing workers so that the firms get highly productive workers and thereby they can increase the total output of the firm. And also, as the workers become more productive with increasing skills, their wages will also start increasing at an increasing rate. Thus, the O-ring model of the positive associative matching relies on two strong assumptions. Firstly, workers must be sufficiently imperfect substitutes for each other. Why? Because if they are not imperfect substitutes, that is, if one high-skilled worker can be replaced by say two low-skilled workers, then there is no prediction of matching, and so there is no positive associative matching as well. Any mix of workers could be possible in equilibrium. And the second assumption is that there must be sufficient complementarity of tasks. And if there is not, what happens is two high-skilled workers and two low-skilled workers will produce exactly the same level of output as two pairs of high and low skilled workers. So yet again, there will not be any positive associative matching, which is why Kremer proposes that sufficient complementarity of tasks is necessary. The O-ring model can also be associated with the migration of high-skilled workers from less developed countries to developed nations with higher wages. Now, this process is called the brain drain. Now, this process can also lead to the less developed nations being left with low skill level equilibrium traps, because all the high-skilled workers will be migrating from the less developed nations to advanced nations wherein they can be more productive and they will get higher wages. So, these less developed nations will be left with low-skilled workers. Thereby, they will be left in the low skill level equilibrium traps. Hope you all have understood the main aspects of O-ring theory of economic development. If you like the video, do subscribe to my channel and share the videos to the maximum. Thank you.